Hello students, നമുക്ക് ലൈൻ ഇന്റഗ്രൽസ് കണ്ടിന്യൂ ചെയ്യാം. So how to evaluate line integrals? Practically we cannot use that definition which we defined like this in the previous video. The definition was integral over C f ds is equal to limit of this Riemann sum. So what we do is it's a result from advanced calculus. We have to accept that result. So integral over C f ds is equal to theorem this is for the evaluation of line integrals. Integral over C is a smooth parameterized curve and f is a continuous function defined over a domain which contains the contour C. F ds is equal to integral a to b. So what are a and b? They are the endpoints of the parameter interval f of x of t comma y of t comma z of t. That means f of r of t. R is the position vector of the particle at time t. So r of t is x of t vector I plus y of t vector j plus z of t vector k, or equivalently the triplet x of t comma y of t comma z of t. And for ds what we do is recall what is arc length. S of t is equal to integral a to t modulus of v of t dt. So this is called arc length. What is v? It is the velocity vector. V is the velocity vector. V of t equal to dr by dt, which is equal to dx by dt comma dy by dt comma dz by dt, that vector. Dx by dt, dy by dt comma dz by dt. And what is meant by modulus of v of t? That means the length of the vector v of t. That means square root of dx by dt whole square plus dy by dt whole square plus dz by dt whole square. And by fundamental theorem of calculus, I have s is differentiable and ds by dt equal to value of the integrand at the upper limit. That means modulus of v of t. Okay, let me write this as tau instead of t, because t is used here in the upper limit, so the dummy variable is denoted by tau. D tau. So ds by dt is value of the integrand at the upper limit. That means ds is ds is modulus of v of t dt, and this ds is substituted by this value, modulus of v of t dt, modulus of v of t dt. And this theorem, its proof is from advanced calculus, you don't have to worry about it. This is how we evaluate that line integral. Okay, we will see an example. Integrate f of x comma y comma z equal to x minus 3y square plus z over the line segment C joining the origin and the point 1, 1, 1. So answer, first we can draw this contour C. So what is that? It is a line starting at the origin and ending at the point 1, 1, 1. So let us plot that curve. Let me erase this part. This is not required. X-axis, Y-axis, Z-axis. This is the origin. 1, 1, 1 is in the first octant. This is the line segment C. And what is the domain of f? It's not given. If it is not given, then the domain of f is the largest possible subset of the xyz space, such that this expression makes sense. And this expression makes sense for every point x, y, z in the space, because this is just a polynomial in x, y and z. Such polynomial expressions are valid at every point. The evaluation makes sense. Okay. Now the first step to find this integral is we parameterize this line segment. So this is the parameter interval. So how do I parameterize? So C can be parameterized as vector r of t equal to, you know, parameterization of straight lines. So apply that. So it is, you can get a ti plus tj plus tk. T varies from 0 to 1. Okay. Now what is the velocity vector? V of t is differentiate component wise dx. So this is x of t, this is y of t, this is z of t. All are equal to t. So dx by dt is 1. So vector I similarly plus vector j plus vector k. Now what is modulus of v of t? Modulus of v of t is square root of 1 square plus 1 square plus 1 square square equal to root 3 and my integrand is f of x comma y comma z is equal to x minus 3y square plus z. So what is f of x of t, y of t, z of t? X of t, y of t, z of t is f of x of t, y of t, z of t is x of t square. Sorry, what is f? F was x minus 3y square plus z. So this is f of x comma y comma z. So this is x of t minus 3 times y of t square plus z of t so you will get x of t is t minus 3 times y of t is t again, so you have minus 3t square plus z of t is again t. So this is 2t minus 3t square. This is the composite function f of r of t. This is f of r of t. F of r of t is this, equal to. So now how do I integrate this? Integral over c f ds is equal to integral over the parameter interval. So 0 and 1 are the endpoints of that interval. Integral 0 to 1 f of x of t, y of t, z of t. It is 2t minus 3t square. Now mod v. What is mod v? Mod v is root 3 for all t. So root 3 dt. So you have to just evaluate this integral as usual. So it is root 3 times 2 into t square by 2 minus 3 into t cube by 3. Between the limits 0 to 1, 2 to cancel, 3 cancel. So it is root 3 into 1 minus 1 minus 0 minus 0. So which is equal to 0. So the answer is 0. Okay. We will modify this question a little bit. So as next example, f is the same. Evaluate integral over c. F is the same. With respect to arc length, you have to integrate. C is different from the previous example, where C is C1 union C2. C is equal to C1 union C2. So what are C1 and C2? I will tell you. This is x-axis, y-axis, z-axis. This is origin 0, 0, 0, and this is the point as in the previous example 1, 1, 1. here is the point 1 comma 1 comma 0, and this line segment is your C1, and this line segment is your C2, and C is the union of these two. Okay. F of x comma y comma z is x minus 3y square plus z C1 is the line joining 0 0 0 and line joining 0 0 0 and 1 1 0, and C2 is the line joining 1 1 0 and 1 1 1. So answer, we have additivity property. So what is additivity property? Of line integrals. So if a contour C is made up of non-overlapping contours C1, C2, etc. Cn, then integral over C is equal to integral over C1 plus integral over C2 plus etc. plus integral over Cn. And these contours are joined end to end. That means the final point of the ith contour is the same as the initial point of the I plus first contour. If that happens, then integral over C equal to integral over C1 plus integral over C2 plus etc. plus integral over Cn. That is additivity property. Integral over C is the same as integral over C1 plus etc. plus integral over Cn. Integral means line integral. So this is C1, this is C2, this is C3, this is C4, etc. This is Cn, like that. C1, C2, C3, etc. This is Cn. And C is the union of all this. The end point of C1 is the initial point of C2, etc. and so on. If that happens, integral over C equal to integral over C1 plus etc. plus integral over Cn. So this is a T property. We will apply that here, and I can write integral over C equal to, C is this, this union this, C1 union C2. So by additivity property, integral over C equal to integral over C1 plus integral over C2. So what is C1? I have to parameterize R of t equal to. And what is C2? I have to parameterize R of t equal to. So for C1, what is parameterization? You can write as Ti plus Tj plus 0k. C1 can be parameterized as Ti plus Tj plus 0k. Where T varies from 1. And for C2, R of t can be parameterized as 1i plus 1j plus tk. 1i plus 1j plus tk. That means I plus j plus t times vector k. Here also 0 less than or equal to t less than or equal to 1. Okay. Now for C1, what is the V of t? V of t is I plus j and for C2, what is V of t? It is simply k. Okay. Now what is modulus of V of t for C1? Absolute value of that vector is root 2, and here modulus of V of t for C2 is 1. Okay. Therefore, what is our f? Remember, our f is x minus 3y square plus z. So integral over C1 f ds is equal to integral over the parameter interval 0 to 1 f of x comma y comma z is this. So over C1 f of x of t comma y of t comma z of t is, what is x? It is t. What is y? It is t. And what is z? It is 0. So t minus 3t square plus 0 into modulus of v of t. It is root 2 dt. So which is equal to root 2 into t square by 2 minus 3 into t cube by 3 between the limits of 0 to 1. So that is equal to root 2 into 1 by 2 minus, here 3 and 3 cancel, 1. In the lower limit it is equal to 0. So it is root 2 into minus 1 by 2. So this is equal to minus 1 by root 2. Now integral over C2. Integral over C2 f ds equal to integral 0 to 1 what is f of r of t? It is x of t minus 3y of t square plus z of t, right? So it is x of t is 1. So 1 minus 3 plus t. 1 minus 3 plus t, right? 1 minus 3 plus t, and modulus of v of t, it is 1 dt. So it is minus 2 plus t integral from 0 to 1 dt. So this is equal to minus 2t plus t square by 2 between 0 to 1. So this is equal to minus 2 plus 1 by 2. So what is this? It is minus 3 by 2. Therefore, integral over C. C means C1 union C2 f ds, which is equal to the first value was this one, minus 1 by root 2 integral over C1. F ds is minus 1 by root 2 minus 1 by root 2 minus 3 by 2. So this is the answer. The point you have to observe here is that even though in the first example and in the second example the initial and the end points of C are the same. Initial point was the origin and the final point was the point 1, 1, 1. The value of the integral in the first example, that means the straight line joining this point to this point, that integral is different from integral over C1 union C2 in the second example. That means the value of the integral depends on the path, not on the initial and final points. So why that happens? So in general our conclusion is the value of the integral depends on the curve C. The value of the integral depends on the curve C. Another thing which is very important, which I forgot to mention, the value of the integral does not depend how C is parameterized. I can parameterize the curve in one way, you can parameterize your curve in the same curve in another way. But integral over C f ds will be the same. That means my answer and your answer will be the same. That means the value of the integral is independent of the parameterization of the curve. But this example shows the value of the integral depends on the curve. In the first example, the curve was from the origin 0, 0, 2 to the point 1, 1, 1, and that was the straight line. And the value of the integral was found to be equal to 0. But in this example, the value is non-zero. So the value of the integral depends on the path, but not on the parameterization. So that is the remark we can conclude. Another thing is, suppose f is equal to 1. F is equal to 1. So remark, so integral over C, f is equal to 1. So what is this? 1 ds. So it is actually integral a to b f of x of t, y of t, z of t. That is again going to be 1, and ds is modulus of v of t dt. 1 into modulus of v of t dt. What is this? This is precisely the length of the curve. Do you remember? Length of the parameterized curve C. So if the integrand is equal to 1, then the line integral represents the length of C, arc length of C. Thank you.